You are welcome to the last part of our introduction to thermal expansion. In this section, we will see how thermal expansion has been of advantage to man, and also how thermal expansion, if not properly handled or ignored, can be of a very destructive disadvantage to man. One of man's greatest inventions using thermal expansion is a small device called bimetallic strip. We take two different metals, like brass and iron, and bond them together. Now, given the same temperature rise, brass expands much faster than iron when heated. So when the strip gets hot, it unevenly expands and curves, with brass curving outward, leaving iron inward. If the strip were to be cooled with the same temperature difference, again, because brass responds faster than iron, it will contract more than iron, causing the strip again to curve. This time, the brass will curve inward, since it has reduced in length more than the iron, while iron will take the outer position. We use this bending action of the bimetallic strip as an automatic switch. It is the secret inside your domestic automatic electric iron. When the iron gets too hot, the strip bends and cuts off the electricity so your clothes don't burn. When it cools, it straightens out and turns, makes the electric contact once again, and turns the heat back on. The bimetallic strip is also used in fire alarms to trigger bells when a room gets hot. Thermal expansion, on another hand, can be a major disadvantage and a destructive force if ignored. In massive engineering projects like bridges and steel structures, heat can twist thick steel girders like paper. If engineers don't place one end of a large bridge on moving steel rollers to allow it to expand and contract freely, the bridge will tear itself away from its concrete foundations, collapsing completely. Imagine a massive steel bridge on a scorching summer day. As the sun beats down, the heat forces the atoms in the steel girders to vibrate intensely and push apart. This causes the entire bridge to physically expand and grow longer. If both ends of the bridge were bolted rigidly to their concrete foundations, this expansion would create an unstoppable destructive force. The expanding steel would buckle, twist, and literally tear the bridge away from its concrete supports, causing a catastrophic collapse. To prevent this, engineers anchor only one end of the bridge solidly. The opposite end is placed on massive moving steel roller bearings. When the temperature rises, these rollers allow the giant steel girders to smoothly slide forward over the concrete piers. When the weather cools, the bridge contracts, and the rollers allow it to safely glide back. By transforming a destructive squeezing force into harmless, controlled rolling motion, these rollers allow the bridge to breathe and stay standing. Whether you are a student preparing for an exam, a carpenter building a roof, a mechanic fixing a car, or a parent in the kitchen, understanding thermal expansion keeps us safe and helps us build a better world. To summarize our lesson, heat makes matter expand by pushing its atoms apart. It affects solids, liquids, and gases. It can be a tool to help us, or a force that destroys our structures if we do not plan for it. In our next lesson, we will look specifically at how solids expand and learn how to calculate it using simple math. See you in our next class.
Udimking Education Foundation. Building confidence, ending examination malpractice for a better tomorrow.
We are building a better tomorrow.
Join us in shaping futures through integrity and education.